So we've mentioned several times at this point that mechanical engineering consists of many, many, many different subdisciplines of mechanical engineering. Um, Now, that is very, very true. But oftentimes it can be helpful to kind of bunch those together into three broader kind of sub-discipline categories. And what we're going to introduce are three different categories that I think are very well aligned with our curriculum and, well, very well aligned with our curriculum at Cal Poly Humboldt, as well as being very well aligned with our expertise areas. So those being system design, energy, and biomechanical engineering. So we can kind of see these three broad categories here. So what's composed of system design? Well, we can think of these as there are some courses that are related to system design, and there's also some careers that are related to system design. And you can think of those, and system design is actually one that requires quite a bit. So statics, dynamics, vibrations, materials, manufacturing, machine design, controls, robotics, instrumentation. These are all the courses that are really at the core of the subdiscipline or of some of the subdisciplines that can be bundled under system design. And when you're thinking about some of those careers that are in system design, you can think of robotics. So robotics is all about designing a system, designing a machine. And again, you can think of, again, a surgical robot. You can think of, robots that are sensing. You can think of Boston Dynamics, those cheetah robots. You can think of autonomous, vehicles as well. All of those are robotic systems, soft robotics, haptic devices. There's tons that are available. Aerospace, designing an airplane, designing a space shuttle. Those are, again, designs of systems. Those are machine designs. Automotive industry is all about system design as well. Defense, tanks, munitions, body armor, all of those things. Electronics, Apple, Amazon, Meta, all those places, when you're designing those, systems, Dell, NVIDIA, lots of those places, they all need mechanical engineers because typically you're looking at heat and these devices and how do you design those systems. Again, there's a lot of mechanical engineers that are hired there as well. So that's very, very important to realize. The next subdiscipline is energy. Now, we have at Cal Poly Humboldt an energy systems engineering degree. However, there's a lot of mechanical engineers that work in industry, in energy, and these fundamental courses, thermodynamics, fluid dynamics, heat transfer, thermo 2, finite element, these are all really, really critical courses that are related to the broad field of energy. And we're thinking of, again, careers that you can pursue, designing batteries. That's really a lot of material science engineers and basically mechanical engineers. Wind energy, solar energy, all mechanical engineering's concepts are integrated in these fields. Computational fluid dynamics. So energy is really, you can think of heat and transfer and fluids. Heat and thermal analysis. Again, that is an energy-related field as well. And finally, one of the very unique things in our program is we have lots of courses that are related to biomechanical engineering. And this is actually a term that Dr. Lee kind of coined in some of her papers previously. So in biomechanical engineering, you're going to be looking at manufacturing courses, materials courses, statics, dynamics courses, heat transfer, solid mechanics, robotics, advanced materials. And for biomechanical engineering, you can look at developing prosthetic devices, creating robotic surgical systems, integrating some mechanical concepts into surgical procedures or devices. And if you really start to, love biology a lot, you can go to medical school. We have lots of students that end up pursuing medical school from mechanical engineering. So that's really, really important as well. So that is a really, really broad overview of some of the things that you can possibly do in mechanical engineering and internships and lots of other things that you can kind of pursue. So I hope that was informative and helpful, and we'll see you in the next video where we start to talk about what are the fundamental mechanics courses that you should seek to master in our program. So we'll see you in the next video. Thanks. Bye.